Greetings, everyone. Thank you for joining the mineral process modeling and simulation level 1 basics course in JKSimMet. Probably you are wondering why and how is this course relevant, or what is the importance of learning JKSimMet. What is the purpose of understanding a steady state simulation software like JKSimMet? How does it relate with your day-to-day work, and also how it relates to your project work? So the big question is why every process engineer or metallurgist must learn this skill. In today's mineral processing industry, engineering intuition alone is no longer enough. Plants are now bigger, ores are now more complex, margins are now tighter, and decisions must be made faster and with great certainty. The modern metallurgist is no longer defined only by plant experience. They are now defined by their ability to predict, to simulate, and to optimize performance, right? So this is where steady-state softwares or tools like JKSimMet fit in. So we view JKSimMet not just as a software, but we view it as a digital representation of mineral processing reality. So if you have got a process that you are working on, or a project that you are working on, we will be able to make a model which is a replica of that process using the software, and make some changes as if we are making those changes on a real plant. So there is a real we view it as a digital representation of your mineral processing project or plant. So that's one aspect that the software help us to dive into the future on a digital screen, even if the plant is not in existence, or the plant is in existence but we want to explore our optimization strategies. So in short, JKSimMet, or learning this skill for mineral process modeling and simulation, it helps engineers to translate the test works into predictive plant models. You're going to see during the course of the training that we can incorporate plant survey data into our model so that we meet the reality of your operation. So works for test works can be converted into predictive plant models. JKSimMet, it helps you to understand every unit operation that is in the circuit. You can evaluate changes without risking production. Like I said, you can interact with the digital representation or model and make changes without first making changes or implementing them on the real production. So your optimization goals, for example, optimization of throughput, recovery, energy consumption, can be implemented and tested using the software before implementation. So steady-state softwares like JKSimMet, they empower engineers to test ideas, safety, in a more quickly and intelligent way. So if you are able to learn modeling and simulation and application of softwares like JKSimMet, it changes your career as an engineer. You stop guessing and you start quantifying. and you start reacting to problems and start anticipating them, which is one of the great qualities of an engineer, to be able to identify problems before they occur and to avoid problems before they occur. So you can be able to diagnose bottlenecks with the data, not with assumptions. You can compare your design alternatives with confidence. That's one beauty of simulation softwares. They give you ability to make different conceptions, several conceptions, and being able to compare them within a very short period of time. So this gives you confidence if you are a design team or you're working on a project. This gives you confidence in your data-driven decisions. So this actually helps with the communication, your technical decisions, and with your management and with your stakeholders, maybe with your clients. So this language, you can speak better language to EPCMs. Let's say you are working with the EPCMs or you are working with consultants. This gives you a data-driven way of evaluating your decisions and evaluating whatever communication that will be happening between your EPCMs or your clients or your consultants. So this skill, ultimately, it gives you an edge ahead of your peers. You gain industrial relevance and professional credibility. So engineers who understand simulation technology and are able to apply tools like JKSimMet, they are the ones which are ideal for lead studies, for validation designs of projects, reviewing proposals, and also they support critical operational decisions. So that's one advantage of having this skill as an engineer. For recent graduates, this is a very important tool because learning JKSimMet and simulation technology, it bridges the gap between your theory from university and the real plant behavior, right? And also for experienced engineers, this is an upskill or a tool that will help you in your day-to-day or project work. It couples your experience as for example, as a plant operator or as a design engineer. So aspects like cutting design cycle time will be achieved by your application of simulation tools, as you'll be able to firstly evaluate some concepts and make well-informed data-driven decisions. So there are various areas that you can apply JKSimMet to solve problems. So for example, imagine you have a grinding circuit which has got a bottleneck limiting plant throughput, right? So the concentrator can consistently fail to achieve nameplate throughput, right? And for example, some plant operators can believe that the SEG mill was undersized and capital expansion was being considered. So for this type of problem, you can now apply simulation technology and JKSimMet, to be specific, to have a full SEG mill circuit model developed in JKSimMet. You do your plant survey and use it to calibrate the breakage and classification parameters, incorporating this into your model. Then you perform some multiple scenarios, right? Bore chart changes, grade design, cyclone apex sizes, and feed distribution. Changing all these and receiving results for each and every scenario. So you can be able to review the true bottleneck. For example, maybe the true bottleneck can be found that cyclone inefficiency is the true bottleneck, right? Maybe not mill power. So you can avoid capital expenditure on a new mill, right? Just imagine the amount of savings that you would have done through this data-driven decision. So these are some of the examples that we can use the software to solve real problems. So this software can be used in scenarios whereby you don't have an existing plant, or you're designing, maybe it's a greenfield project or an expansion project. You can apply JKSimMet, or you can apply this tool for optimization purposes for an existing plant. So this is going to be a very useful tool, and you're going to gain very important skills and knowledge throughout the training. So see you inside the training. Thank you.